Hello, this is teacher and welcome back to my videos on Mastercam. Okay, and today I want to make a series video to make a comparison between two popular 3D finish toolpaths. The first one is the Waterline finish and the second one is the contour toolpath. As you know, these toolpaths are very popular and they have the same way of working, the same strategy. For finishing, they use the constant depth upcut for doing the finish. Yes, and the new one is the Waterline Mastercam corners, the high-speed finish toolpath, and the other is the old school finish contour. Okay. And in this video I just want to talk about how these toolpaths they handle the shallow area on the part. And in other video I will compare the other side, yes, other property of these toolpaths. But in this video I just want to talk about how the Waterline and the contour toolpath they handle the shallow area on the part. Okay. Let's take a look on the screen. You can see I have two similar parts. This part I just created for demonstration, so it's not a real part, that's just for demonstration. Okay. And this part is for testing with the Waterline and this one is for the contour. You know, when we work in a 3D part, we have some kind of area. We have the vertical area, vertical wall like this one, and we have horizontal like this and this one, and we have steep surfaces. Yes, you can see these are the steep surface on the part. Steep surfaces, yes, it is almost vertical, we call it the steep surface. And we also have the shallow surfaces, which I mark in red. You can see here in red. And these are the shallow area on the part. And you know, when we use the Waterline or the constant Z upcut, it will pretty cool when we apply it on steep surfaces, and it's not so good for the shallow area. Okay. But if you want to finish shallow area with the Waterline or the contour toolpath, they also allow you to do this. So let's see how they work. Okay, I will make a analytic angle and trap angle, and you can see, pew! Yes, you can see this now, easy to see. We have some green surfaces. Here is the vertical wall on the part. Yeah, 90-degree vertical wall. Okay, and we also have this color is represent for the horizontal area on the part, or the flat surface, the floor on the part. And yes, sometimes we call this floor, and the vertical wall we call it the wall. Okay, and you can see this color. This color is represent for the steep surfaces on the part. You can see we have some steep surfaces here and around this island. Okay, and the rest is marked in red color, in red here. That and yeah, in here on this fillet you can see the area that have small angle. Yes, small angle value, and we call this area is the shallow area. You can see, yeah. Alright, and for this part I just make some roughing operation for roughing, and this is the stock. You can see this is the material, the stock after we do the roughing, just for demonstration. Okay, and now we are going to make Waterline finish toolpath. We will start with the Waterline toolpath. Okay, we go to the toolpath here and select Waterline. Okay, and we select the machining surface. Okay, we select this solid for the waterline, and the stock to leave on wall and stock to leave on floor is 0 because we do a finish cut. Okay, and you can add a boundary if you want. Okay, and we select the tool for the finish operation. Now I'm gonna select the 6mm ball mill. Okay, and here in the cutting parameter we will select the depth of cut. Okay, I will select 0.2mm depth of cut. Alright, and transition 2° ramping. Okay, and I put some parameter for the lead in and lead out. In the Waterline toolpath, because that's a 3D high-speed toolpath, so we have some option for high speed linking between the area. Okay, and we set the tolerance for the toolpath here, set 1 micron. Alright, and we wait for the calculation. When I playing with the Waterline, sometimes it make me feel crazy. Oh my god, and I feel I lose all my control on the toolpath, and I can't do anything to change it. Okay, so this is the Waterline. You can see it cut from the top to the bottom of the part like this. We have some lead in and lead out. And look at this. Okay, we look from the left. You can see when we look from the side, is a constant depth of cut, but when we look from the top here, on the shallow area, here on the red area here, and on the top here on the fillet, you can see the step over is very large here. Yes, and it will make a unconstant look on the surface when it finishes. You can see it. The step over here on this area is very large because of the shallow area. Alright, now we will take a simulation so you can easy to see. Okay, now we do the finish. And yes, this is the Waterline. They're doing the finishing. I just finished the horizontal area using the horizontal toolpath, and you can see this is the part after finish. I will turn on the accuracy zoom. Choo. So you can see it's yes, clear. You can see on the steep surface here, the surface look good with small step over, but on the shallow area here, yeah, you can see very large step over on the shallow area, and it's not good for the part surfaces. Yes. Okay. And we have the same problem with the contour toolpath. Yeah. But now we just want to talk with the Waterline first. Okay, so how do we change the step over in this shallow area? Mastercam Waterline allow us to do that by using the add cut option here. We turn it on. We turn this option on. and you have the minimum step down value and the minimum profile step over. You can change this to 0.2 to make a constant step over, so it will limit the step over and it don't let it too big. Okay, and we limit the step over, the maximum step over is 0.2, and we regenerate the toolpath again. Both the waterline and the contour toolpath have the option for you to adjust the step over on the shallow area, so don't worry about it, but just see how they work. Okay, we need to wait for the calculation. Okay, now it's look better. You can see when we look from the top view, the step over is in degree and it's small now. It looks smaller and the surface is better. Yeah, now it's smaller. You can see that when we activate the add cut function. Okay, but this is the problem. Look at this. When we take a look from the right side, when you adjust the step over on the shallow area, you can see on the steep surface here, right here, you have unconstant. The step over here is about is 0.2, but you can see on the shallow area here, the step down they decrease. Yeah, so we have a not constant depth of cut. Yeah, you can see on this area, you can see this is constant Z depth of cut 0.2, but in this area, because we add cut here on this shallow area, we have some unnecessary move here which make the surface unconstant. Yeah, look at this. We change to make it smaller so you can easy to see. This is the crazy thing I want to say about the waterline toolpath. We can do nothing. We can't do anything with this. We cannot change it, and we have to accept that if we want to use it. So I feel I lose all my control on this toolpath, and we have to follow it. It take a while for doing the calculation. Okay, see that? Yeah, it's now easy to see. When you add the cut in the shallow area here, we have some crazy move here. It also add the cut in the steep area. That's what we don't need. It's not necessary to add the cut here, right? We want a constant depth of cut on the steep surface. But you can see when we add the cut here, it automatically add the cut in the steep area. So it's crazy, and we don't want it. It will take much longer to finish the part, and this is the movement we don't want. You can see that right here. So it's crazy. Now let's do a simulation again. Finish the part with the horizontal. Finish the flat land of the part first. Okay, and now we finish outside. Alright, acrorism. You can see now is much better on the shallow surface. but it takes a lot of time to machine this because we have unnecessary move on the steep surface here, and this not optimization. We don't want it. We just want to add the cut here on the shallow area only. We don't want to add the unnecessary move here. How to remove it? The Waterline don't allow it to do that. They have no other option to remove unnecessary cut. That's crazy. I don't like it. Alright. Okay, now we come to the finish contour. Dang, dang, dang. We go to the toolpath and contour. Yeah, this one. And now we will test on this solid. Shoo, boom. Containment. Alright. Ding, ding. We go with the same tool and the same parameter. Alright. Okay, and for maximum step down, we also use 0.2, the same with the Waterline toolpath. Okay, 2 degrees. And in the first time, we have not activated the shallow option. This quite similar to the Waterline and how this works, just constant depth of cut. Alright. So this is the finished contour. It's just the same here on the shallow area. We have a very last step over. Yes, we have to modify it. So to add the cut on the shallow area, we activate the shallow option here, put on this, and we set the limit angle. So if the angle of the surface is smaller than this angle, you can add cut to this area. Okay, so we also have the minimum step down, and we also the limit step over. Okay, I will use the same value on with the Waterline toolpath. Okay, and see what we have. We regenerate it again. Tum 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 tum. And sometimes because of this, I want to use the Waterline. The finished contour, the old school contour. I don't want to use the Waterline. Okay. You can see that at first we have more retraction. Yes, a lot of retraction here, but look at this. You can see it's only on the surface finish contour toolpath. It's only at the movement on the shallow area only, and on the wall here it's not add unnecessary cut. Okay, I will turn on two toolpaths. You can easy to see. This is the Waterline, and this is the finished contour. You can see on the Waterline unnecessary cut here, and on the finished contour we have some retraction, but we don't have the unnecessary cut here. Yes, that's what I like on the on the finished contour. And let's check the cutting time. Time here is about 12 minutes. And how about here? We have about more than 30 minutes. 13 minutes. So it's 1 minute longer. But for a bigger park, it will take more time. So you can see we have the same cutting parameter. We have the same depth of cut, but the Waterline takes longer because the unnecessary cut here, that's what we don't want. Here on the contour toolpath we have more retraction, but it's removed unnecessary cut. So if you want to remove this retraction, we want to reduce this. The surface finish contour have one more very cool option, that's the direction of open contour. So if we change it to zigzag, we will have less retraction like this. Wait a moment. So this is how the old school work. It's pretty cool. Choo! You can see we have less retraction, right? We have some zigzag motion here, and we doing with the gap setting. Maybe fine to see. Optimize cut order. Okay, when we turn on some option, and we got some nice toolpath. So that I want to say, when we work with the old school toolpath, we have more control. We can make the toolpath follow us, not we follow the toolpath. As you can see, we have less retraction. And we have some zigzag here. Yes, so this is the comparison between the waterline and the finished contour when it has to handle the shallow area. Okay, we'll try something to make it can make it better. So this is the topic of today's video. I just want to talk about how the waterline toolpath and the finished contour they handle the shallow area. And in the next video, I will come back. With another topic on these different toolpath. Okay, right? This contour and this is waterline. Very cool. Okay, thank you for watching and see you in the next video. Goodbye.